So we have talked before about how to graph lines, and when the equations look like this, we can make a t-chart, plug in 3 points, and then put it on a graph, kind of like that. Okay, and it'll look like that. Very basic, and of course that's me rushing through it. However, there are multiple ways to graph a line. And we're going to talk about a different method for doing that today. When you look at this, we tell you to graph 3 points. But in reality, to determine a line on a graph, you only need 2. Every line that exists, anytime you put 2 points on a graph, there's only one line that exists that passes through those 2 points. So for instance, on this one, there's no way, if I talk about these, if I talk about the outer 2 points here, there's no way I could draw another line that passes through those 2 points that does not pass through the center point, okay? So when we tell you to find 3 points, what that does is it helps you make sure that you're doing it correctly and not making any errors. Now, one thing you've probably noticed is that when you have an equation that looks like this, I apologize, that looks like this, that it's difficult to graph it this way, because when you plug in your x, you end up having to solve an algebra problem every single time you want to figure out what y is. Well, with these particular types of equations, you'll see that there's another method that works a little bit easier, and that's called intercepts, okay? Now, what are intercepts? Those are the places where a line crosses these 2 axes, okay? This being our x-axis, and this is our y-axis, okay? So, any line that crosses through these, let me change the color of it, that crosses through these, this would be its y-intercept, because that's where it touches the y-axis, and this would be the x-intercept. And what we can do when we have equations like this is find those locations where it's crossing these axes, and when we find them, we can connect them and we'll make the line for the equation that we're looking at. So one thing that's fortunate for us is that on an intercept, you're talking about the places where, on an y-intercept, okay, you're talking about the place where x is equal to 0. And on an x-intercept, you're talking about the place where y is equal to 0. And these zeros make it actually pretty easy to graph an equation in this format. So, for instance, the best way to describe this is to talk about pretending like these things no longer exist. So if I have x is 0, okay, what that means is, you're multiplying by 0, and that means it goes away. So in this situation, I'm going to say x is 0, so 3y equals 6. Well, that's just 2. Okay, so I'm going to write in 2 on the y part. And then I can do the same thing on the other side. I can say that when I plug 0 in for y, that it is going to disappear. And now I've got 2x equals 6. The plus sign would also go away, but 2x equals 6. Well, that means then that I want x to be 3. If 3y equals 6, if 2x equals 6, then x must be 3. And then I can graph those 2 points, connect them, and I'll have my line. So again, with Rick and his super ugly graphs, okay, I'm going to be estimating here, but I'm going to do x0, y2 is going to be about right there. So pretty. And this would be about right there. I put those 2 points, connect them, and ta-da, I've graphed it. And I didn't have to move any variables around or anything like that. Okay? Let me do one more real quick, and then we'll be done. All right, so let's say that the equation is 3x minus 5y equals 30. I'm not going to use the illustration this time because I think you can do it on your own. If I plug in x, 0 for x, you know what? Let's use the illustration. Why not? Okay, and that goes away. I've got negative 5y equals 30. Well, to solve that, it's just going to be negative 6, because negative 5 times negative 6 gives me a positive 30. And then let's say I cover up the other element because y is 0 now. Well then, 3x equals 30, so x must be 10 when y is 0. Then I would put those on a graph, and you're going to do it much neater than Rick is doing right now. Graph it, and that would be what you get. Okay, so this method is called intercepts. This is the intercepts method of graphing. You can use this no matter what form it's in, but when it's written like that where x and y are on the side by itself, that's generally the easiest method. So you'll practice using this on a bunch of different problems, and so we'll see you in class. You can ask any questions that you might have.